Okay, good morning to everybody from still sunny Darmstadt, and we hope to stay like this. Germany, even Spanish speaking. I'm presently, as you see, at the EUMeTrain headquarters in Darmstadt. Our second presenter, which is Taimi Paljak from um, Estonian Met Service, and she will brief us on the weather more in details. So now my question is, and I'm putting this to you for a purpose to make you think from the other angle. So there is a map of Europe, but if there is somebody outside of the Europe, please, you can write on the screen as well using these tools. Oh yes, we see a lot of stars from Estonia. So Litva as well, Russia, Belarus, great Germany, even Denmark, yes, or North Germany, I'm not sure. Poland, Portugal, Spain, great Serbia, even the southern parts. So I'm happy to see 28 names actually for this session. The session should be up to 45 minutes. We will try to keep it as prompt as possible. So thank you for your answers. We're moving on. I just wonder, what is your occupation and what do you do in everyday work? Can you place a star over word you think best describes your activities? Okay, we have a lot of forecasters, as expected, part-time forecasters, trainers as well. That's good. Other weather business, also nice to see, and maybe the best to see weather enthusiasts. Uh, there are people that are not sure why they here, but if nothing else, we will try to entertain them. So help me with that as well. Okay, good. Moving on. Um, what we will tend to do today is so-called SATREP analysis. SATREP comes from two words. It's short for SAT as a satellite and REP as a report. So we'll try to do something like this, and I will actually need the full support from your side. I have to admit I'm really not a forecaster, and I never actually worked as a full-time forecaster, so I strongly need your help with this one. So let's hope we will solve the puzzle at the end, and we'll have something like this at the end of the session. Okay, so my first question to you, you can use the text chat, I forgot to say. So if you can tell me what is the image that you see, you can write in the text chat or you can draw letters on the screen. So maybe if you can mention channel or the part of spectrum we are in. Okay, I see water vapor, great. Water vapor 6.2, good. 6.2, closer and closer. Um, Actually, you got it right. It's 6.2 channel, but there is one side to it. It's not the satellite channel. It's not the satellite image, but yes. So Laura guessed it. Pseudo water vapor. Yes, that's nice. So what does this mean? It means that the fields, temperature and moisture fields were taken from the model and assimilated through the radiative transfer model, I'm sorry. And there you have simulated radiances as the satellite would see, having the background of moisture and temperature fields as they would be in the real atmosphere. So if you compare, it's always nice to see this image first when you start your forecast, because it gives you the real quick view and quick check of the model performance for these days. So if I toggle between these two images, so the first one is the pseudo or NWP model image, and the second one is the real water vapor 6.2 image from the Severi instrument. You can see that today models are performing quite nice. I see the black stripes at the similar places, the white cloud bands as well. Mostly the mesoscale features are not well picked by models, but this is the fact that you are aware of. And for a synoptic approach, this is really, really good to have this as well, the pseudo images. Okay, so pseudo images or the water vapor image falls into infrared range of spectra. And my first question, short refresher, not as a quiz, but it's a refresher. Infrared radiation, what is it? Can you put the star next to an answer you think it's most likely to be the right one? Uh, just to let you know, nobody knows whose star is it, so be free to make stupid answers as well. But anyway, the most valuable thing you can do when you're training or doing your work is to make mistake. That's the thing how you learn the best. So don't be afraid, just do any answer you have. So up until now I see the heat is the winner, longer than microwave. So let's go from the D, answer D, because B and C are not covered, and I'm glad to see that. D, longer than microwave. Microwave range is I think from few tenths of microns to hundreds of microns. So and water vapor is image, or the infrared is basically from 4 to, let's say, 15 microns. So it would not be longer than microwave. Actually, it's shorter than microwave and higher energy. And actually, you can say it's a heat. Heat is actual transfer of energy, but if you think of it as a consequence of the radiation, then the answer would be 8. So good, thank you. And one more question for you, or the refresher, so to say. Can you give me your answer on this one? So water vapor image reflects what features? So the first one, amount of water vapor in troposphere. Okay, many answers there. What about temperature of water vapor aloft? Okay, one answer there. The risk of precipitation. Maybe surface temperature. Let's see, I will give you a few more seconds to think about it. Okay, let's go from the least popular. That's answer D, the surface temperature. Of course not. As I see, you all know, water vapor channel depicts the signal from the upper part of the troposphere. So definitely it's not the surface temperature, although in the higher places and drier places, sometimes you can even see the surface. For example, in Sahara region there is Tibetan mountains, and recently I saw actually the signal from the ground there, from the water vapor. Risk of precipitation? Uh, Maybe not, because not directly. When you see the white and the high clouds, then you can assume it could be maybe a squall line or a CB, and the risk of precipitation is high, but not directly. Number A, the amount of water vapor in troposphere. This is actually not the right answer, because all that satellite gets is the counts or the energy from the molecules and the atoms in the atmosphere, which radiates heat or electromagnetic waves. So the actually the satellite is not capable to measure the real amounts of water vapor. What what satellite measure is the temperature of water vapor that radiates the energy at the level it is situated. So definitely aloft, and definitely the uppermost part of the troposphere. So actually the right answer would be B, but it was a confusing question, a bit tricky, I know. So very good answers, thank you for this. So water vapor, why I'm mentioning it so much, it's really good. As I said, it gives you the information about the temperature uh, of the water vapor in the atmosphere. And by temperature, if you connect temperature with the height, which is a quite straightforward approach, and you can, to a degree, you can do this, then you can you can do your mind mapping of the atmosphere, 3D mind mapping, like one in the image you see. And for that reason, I chose water vapor image today to do the analysis of the weather synoptic. In this image, I think you can see probably it's the jet coming down the dry conveyor belt coming down to cold front, but I didn't check. If you have different opinion, let me know. Okay, good. So thank you so far, but now I will need the full attention and full involvement of you. Um, this is the 6.2. I just wanted you to be aware that there is 7.3 image as well, which looks more deeper into the atmosphere. And if I toggle between these two images, so 6.2, this is not the actual image, so don't be confused. It's just for the demonstration. So 6.0 looks more deep into atmosphere, and it depicts the lower level features because of the weighting function of the channel 6, which is lower than channel 5, which is 6.2 micron. Okay, um, so full attention from your side. Um, okay, Vesa is asking, I see the post in the text chat. 7.3 goes deep into the troposphere. That was his question. And yes, as I say, if you see this normalized weighting functions, the majority, how you can interpret this image is that the majority of energy that comes to satellite is actually radiated at around 450 hectopascal level. So somehow this channel looks deeper into the atmosphere. But also there are contributions from other levels, as you can see, so you cannot say exactly this is the situation at the level 450, but more or less. Okay, we can move on, I guess, and finally we get to the image of the day, which is water vapor 6.2 channel. And what I would like from you is to take a few seconds. I will give you half a minute. Just look at the image and think about the synoptic features that you see. The water vapor really is good in depicting the places where you have maybe Rossby waves, jets, or cyclonic features. So from my point of view, it's maybe the weapon of choice for forecasters to start their day. I'm sorry, start day forecasting day. Um, just to have some kind of clue what is the first guess of the weather. And now I want you to take the pencils in your hand, well, the virtual pencils I showed you before, or the stars. And first of all, if you can show me, or if you have any idea, just draw whatever comes to your mind. Uh, where would be the Rossby wave, the cold, let's so to say, um, polar jet, or the jet position in this image? Or we have many branches of jet here, so you can maybe depict them. So just draw freely on the map as you like. Good, I'm happy to see many colors so far. and actually many similar answers. While you're doing that, I will prompt you to see that to recognize that if you look at the image, the gradient goes from the bright um, pixels to darker pixels towards the southern hemisphere or equator, and that means that the naturally the troposphere is colder in the northern part. So in general, you have this gradient. Okay, so most of you, well, I think every one of you did pick the right places, and the right places would be the dark places. Why? Because the dark places, as you probably know, are the dry areas, and we all know dry areas are connected to tropopause folding or the jets that cause that. And as you can see, we have a quite meandering of the jet today. Um, well, the strongest jet goes in the northern parts, but we have branches meandering to the south, something like this. That would be maybe the general point of view of the synoptic circulation in the higher levels. Okay, let's clean this, all the markups, and let's try to maybe to depict the height, geopotential height contours somehow. Uh, as you know, they're connected to synoptic scale systems, so which are not that prominent today, and it's not really this cool example of the water vapor image. But if you can try, just the first guess, we will try to distinguish later. Okay, I see some closed circles. Good. And I suppose maybe you can put the low L for low and H for high. Okay, we have high and low. Oh, this is interesting. I already can see the pairs of the deformation band approach, so this is nice to see. And I'm not doing anything, running the weather briefing, which is even nicer. I don't have to say anything, and the analyses appear on the screen, which is really, really nice, and I'm happy about it. Good, we see many lows. Actually, I think you are right. There are two prominent lows, one above the, let's see, Eastern or Southeastern Europe, and one between Iberian Peninsula and Northwest Africa. These are the most prominent cyclonic features. Uh, Although they are not new, they are here for some time, so the occlusion is well developed, and as you can see in this area, we have a large occluded area here as well as in this part. So for well-developed system, this is typical. Also, you can track somehow the warm conveyor belt, which is quite developed, and it's branched to left and the right hand side of the system, which also forms some kind of deformations or zone, so to say. And below you have a cold conveyor belt coming this way, but not so prominent. The same can be applied to this area. So you have a warm conveyor belt probably branching like this, and underneath you have a cold conveyor belt wrapping into this occlusion point. Okay, good. The next thing I would like to ask you, I will clean this up, and we need to hurry a bit. I deliberately covered the southernmost part because Taimi will tell us more about the northern part of Europe. But one last thing I would like to ask you is maybe to point the places where most likely we will have cyclogenesis in the next few days or in next few hours, maybe even. How can we find these areas without models? So, okay, we have one on the cloud head. Okay, this is already developing place where the most stars are. Okay, some other areas which are connected to really sharp gradients in water vapor. And what happens there, and I'm happy that you pointed these areas like this, and actually this area. And what happens is that we have a strong intrusion of stratospheric air down from the high levels to low levels. And if you think about the conservation of potential vorticity, um, uh, static stability, if you have the isentropic movement of this air, the static stability decreases, and if you want to conserve the potential vorticity, then the up vorticity needs to go up, and then you have a kind of cyclogenesis area. So you guessed it right. So dry areas are connected to tropopause folding, which means the destabilization of the atmosphere in a vertical cross section, which to a consequence have, if you consider the conservation of potential vorticity, then you have vorticity enhancement in these areas. So thank you again. This was really good to see these answers. Also, there are places like this where you have sharp gradients in water vapor, but this is not so active area, since I think there we have a high pressure and low pressure. So normally you have a movement of air from the high pressure to low pressure, which veers to the right due to the Coriolis force, and there you have stronger winds, which makes a small jet in this area. Good, great. I will clean the screen, and actually will try to run the small animation just to give you the better insight to this analysis that you did. We'll now not go into detail, but as the main idea was for you to see that the basic synoptic analysis can be done only using by water vapor image, and you did it really well. That means probably you use these images, and I really encourage you to do so in the future. I don't know if you can see the animation, but I will leave it. It's the 10 step loop from yesterday and this morning, so more or less overnight. So you can see the things that you pointed are developing in the right direction. So as you can see, you can analyze it as well as the forecasting. So thank you again for a full involvement. And now I would like to introduce again Taimi, and we'll hand the microphone to her. Taimi, go ahead.
Hello, can you hear me? Mhm. Okay. Hello, everybody. My name is Taimi Paljak, and I'm working in Estonian Weather Service in Tallinn. This right picture, this is the nice one from Northern Lights, have been made on 17th of March. We have had since last Thursday approximately 1 week very nice weather with clear sky, with minus temperatures at night and warm days. So the next slide one, I wanted to show that the Baltic surrounding the Baltic surrounding was under the influence of powerful flow, high with stable and very dry air mass. In some days, the relative humidity was only 14%. High center circled around the northwestern part of Russia. It extended up to tropopause and was very powerful. Even in its western part in Estonia, the highest mean sea level pressure rised up to 1053 hectopascal. For comparison, the maximum sea level pressure has measured in Estonia 1057 hectopascal. It means that record is only 4 hectopascal more. The day temperatures has been also unusual high. Here on the chart, you see Tuesday's temperatures. It was even warmer in yesterday. In some places, it was the warmest 18th of March during last 150 years. And maximum temperatures rised in many stations up to 15 degrees. Today it isn't anymore everywhere as sunny as it was yesterday and the days before yesterday, but it's still warm and dry. So on the next slide you can see last night chart from DVD. And high still there in northwestern part of Russia, but it's not anymore so powerful. In the same time, the other eye on the British Isles. So those two band together high belt here. Yeah. Important is that the third high is far there on the north. It formed only yesterday and has strengthened quite fast. Cyclones from Atlantic have to depart more northwards and to choose northwards direction. One has already arrived to Iceland and the others are coming from American coast. And now we can look more detailed the situation in northern latitudes and look at the conditions favorable for the warming or getting colder. Look at the RGB image from last night and it's overlaid with 500 hectopascal. You can see high over the northwestern part of Russia with dry, stable and approximately cold air. From west there is a narrow ridge of high and it's extended to the British Isles, and greenish color refers to warm air mass. In upper level there is between those two highs very small upper level low, and you can see descending dry air mass with reddish color. On the Atlantic there is active cyclogenesis with strong southern airflow, and it is pushing thick cloud band northwards. Interesting situation is on the Norwegian Sea. Over the southern waters there is quite strong westerly airflow. In the northern part, airflow has turned already to northwest. And now we can look at temperature advection and at the temperature advection on the 700 hectopascal. So, and you can see warm air advection approach to the Norwegian coast and following by cold air. And this process is supported by cold air from northwest. The other strong warm advection is pushed to the Greenland and also to Iceland. And from Atlantic there is coming the additional warm air advection. We already looked also to Southern Europe, and I just add that there is quite strong warm air advection from Africa towards Iberia Peninsula. And next one, we can look at frontal systems between the different air masses, and we can look at infrared image, and it's overlaid with thermal front parameter, and I add also omega 700 parameter. Perhaps it's not so good to see anymore this thermal parameter, but they just fit very good together. It is seen the warm front here, and other one coming from American coast, and that's the good see that the parameters fit very well with bronze that we saw already on the DVD chart. In the next slide, I once again show the water vapor image, and it is overlaid with 500 hectopascal and isotachs on the 300 hectopascal. You can see not very strong yet over the Norwegian Sea. The Norwegian Sea. Also, jet on the Atlantic is not very strong, and it is waved, and perhaps it is the sign that the cyclones they are formed on the Atlantic. They are not coming so fast towards the Europe. And what more? You can see the jet on the right hand side of narrow ridge that is extended to the British Isles, and it's very good seeing this jet, and it is quite strong. It is not so easy to see the numbers here, but it's the strongest wind speed, not so strong even on the Atlantic. So, and next one. That's the water vapor image covered by 300 hectopascal and also overlaid with potential vorticity areas. Here you can see that high potential vorticity areas with very good with black areas. That means with cold, dry stratospheric air intrusion on Atlantic and also here a little bit west from Europe. There is also high potential vorticity on the Norwegian Sea and closely related to the cyclone that is just coming to the Norwegian coast. So, and some words about area here near the American coast. There is two very high potential areas, and it can makes more active the cyclones, cyclogenesis here in this area, and it is good conditions forming new upper level low between Greenland and American coastal areas. And here this picture from today's morning. Here you can see that Estonia is with nice clear skies yet, but more high clouds already in the Finland and thick air mass here in Scandinavia, and today the airflow is coming from west towards Estonia, but afterwards it is turning to the northwest, and what it is bringing to us you can see on the next slide. Yeah, and this is output from our Hirlam model, and it is 850 hectopascal, and you can see on the left hand side today's temperature. It is about 5 degrees on the approximately 1.5 kilometers, and on the right hand side you can see tomorrow's situation, and it has felt already more than 10 degrees, and the airflow has turned to northwest already, and later on to the north, and so the winter is coming back for some days. And that's all. Thank you for your attention. Do you have some questions?
Hey, thank you so much, Amy. Yeah, we will take any questions if you would like to, if somebody want to ask something to Amy or me, please go ahead. We still have a minute or two maybe to discuss things. I've seen Tamara's has a comment on the thunderstorm in southern Adriatic. She noticed thunderstorms there. So let's go and see what happens in southern Adriatic. For that case, just in case, I prepared infrared image as well, which goes deeper into atmosphere. Actually, this is 10.8, which is the clearest channel from the water vapor and goes fairly deep into atmosphere, right to the surface if there is no obstacle like thunderstorm cloud, which it could be this small white dot. Um, and she says, are they due to dry wet boundary? And I think that she's quite right, because we have strong dry wet gradient here, and as you know, when you have these strong gradients, it is quite likely for thunderstorm to develop. So thank you for this comment. If you have further questions, you can write into the text chat. I'm happy that Amy showed the ECMWF fields as well, and which reveal the things you already said about the position of the highs and lows. You well depicted them. Also, the potential vorticity height, which is the dynamic tropospheres, was mentioned, and it actually coincided. It was really good um, uh, overlapping with our assumptions. So um, I'm very happy to see that. Okay, if there are no more questions, we can wrap up. Still, you can write them before I say the last words. And these are, thank you again, Taimi, for your participation. It was very nice to see the weather and to hear that this high pressure was almost record one. I was wondering about that. I saw it will go over 1050, but I didn't know if that happened. So thank you also for this feedback. And the next weather briefing will be in almost 1 month, even less, 15th of April, held by Lilian Hofer from Zamg. While mentioning Zamg, I see Andreas in the audience. Andreas wrote a very nice module on water vapor and preparing another one. So please visit the EUMeTrain pages and go to resources, and there you will find the existing module. And soon, I guess within 1 month, you will see another module coming up only about the water vapor, and it's a quite powerful channel, as I said, and you can find evidence there. So thank you again for your attention and for your time. We took a bit more of it, but I hope it was worth it. And this is the image of the first Visibaba, so we call them, flowers taken from Croatia. So anyway, thank you for your attention, and hope to see you for the next weather.